Interest rate derivatives. Let's define what an interest rate swap is. And an interest rate swap is a simple derivative. It's simply an agreement between two counterparties where the counterparties agree to exchange cash flows for a period of time. That's all a swap agreement is. Are there any relationships between a swap agreement and forward contracts? Well, there are. A swap is a series of forward contracts, because remember that a forward contract calls for the delivery of something, and if this forward is cash settled, then that the delivery is basically a delivery of a cash payment. So in that sense, a swap could be viewed as a series of forward contracts in time. There are differences, however. In swaps, the payments are known one period before that payment is made, and in the futures, in a forward contract, those payments are not known until the expiration of that one period forward. So even though swap agreements can be viewed as a series of forwards, there are differences such that swaps are relatively unique. What are interest rate caps? Well, caps are contracts that provide insurance against the rate of interest on a floating rate note going above some pre-specified level. And that pre-specified level is what's called the cap rate. So again, caps are agreements or contracts that provide insurance against interest rates going above certain pre-specified level, which we call the cap rate. And think about who the user of a cap would be: someone that has to pay floating rate and does not be exposed by interest rates going up above certain pre-specified level. Those oftentimes will be purchasers of caps. Let's look at what the payoff on a cap would be. Cap T would be a cap with time to expiration cap T. Is identically equal, the payoff of this at expiration will be equal to the max of either this or this. Zero, everybody understands. There's no payoff to the cap when actually the worst you thought would happen did not happen, and that is the floating rate did not move above that pre-specified level, which we call K, the cap rate. But RS, which is the resetting rate on the floating rate note, is when that one is higher than the cap rate, then the payoff of the cap is found as the difference between these two divided by the present value factor for that rate, multiplied times the time adjustment based on a 360-day year times the notional amount for the note that you're involved in. Again, K is the cap rate. That will be the exercise price for the cap. R sub S H is the floating rate that is reset every H. Let's say it's a 90-day floating rate or floating note that is reset on a 90-day basis, so H would be a 90-day basis. T is the expiration of the cap. Now, oftentimes, interest rate caps refer to a series of caps normally called caplets. So again, the cap is basically has the payoff of an option. It's in the money when the reset rate, the floating rate, is above the cap rate, which is the exercise price. And in order to calculate the payoff of this cap, you just divide that by a present value factor, multiply by a time adjustment, and the notional amount for the floating rate note. What is an interest rate floor? Well, it's exactly the opposite to the interest rate cap. A floor is a contract that places a lower limit on the interest received or charged. In other words, it doesn't place an upper limit, but a lower limit on the interest you can charge. What is the payoff of a floor? Well, is the maximum of the difference between the floor rate and the reset rate. When that difference is positive is when the floor actually pays off a positive amount. And that divided by a present value factor. or 0. So the floor pays nothing when the reset rate is higher than the floor rate, but it pays a positive amount when the cap rate is larger than the reset rate. And again, K is the floor rate, RS is the reset rate, and T is the time to expiration. And remember that, as with caps, floors are actually a series of floors called floorlets. If you combine these two option-like agreements, the cap and the floor, you get what's called in the industry a collar. And a collar is the combination of a floor and a cap, and it specifies an upper and lower limits on the interest to be charged or paid. Specifically, let's say a collar for someone that is concerned about interest rates going up would be going long a cap. That will put an upper limit on what you will be paying, and short a floor. Now this would be your collar, and in the long cap you put the upper limit on what you pay, and that's the insurance against interest rates moving up. And by going short the floor, what you do is offset some of the costs of covering for this exposure. So the idea behind forming a collar is usually reducing the cost of a cap, which is what you are concerned about when you have a commitment on a forward, on a floating rate note, and do not want to pay more than a certain amount. So again, you enter into a long collar when you're concerned actually about interest rates going up, and you short the floor as a means of reducing the cost of the cap. Sometimes if you can reduce the cost or offset the cost of the cap completely, you will form what's called a zero cost collar. And that's pretty much why floors, caps, and collars are used. Let's talk about what normally in the industry is called naked positions versus hedged or covered positions. In the case of caps and floors, owning a naked long cap is a levered bet on interest rates going up. In other words, you would buy a cap only if you think that interest rates would be going up. If you don't have an underlying floating rate note on which you'll be making payments, and you just buy the cap, then that position is called a naked cap, and it's done as a means of placing a levered bet on interest rates moving up. Owning a cap and being short a floating rate, that is, you issue a floating rate and you have to make floating rate payments on it, that is considered a hedge or a covered position. In other words, what you're doing is ensuring that should interest rates, floating rates, go up beyond a certain amount, you will not pay that extra amount because you cover that floating rate with a long cap. So in the second case, you have a hedge position or a covered position. The cap basically covers an underlying short position. In the first case, you have a naked position. It's more speculative than the covered position. The covered position is ensuring, the long cap is ensuring against increases in interest rates. Let's now talk about option contracts and markets, and specifically let's illustrate how the one-period binomial model can be used to illustrate arbitrage in the options market. So let's focus on the data we're going to use. As usually, S sub 0 will be the underlying cash price for the underlying. In this case, we'll consider the underlying to be a share of stock. So the price for this share of stock is $50 per share. The strike price X will be 45. The risk-free interest rate, annual rate, will be 5%. And then we have up factors and down factors. So the up factor is 1.12, meaning that in 1 year, the underlying price can move 12% up or 10% down. So these are 1 plus the either up or down movement. And T will be equal to 1 year. The question is, what is the price of a call option under these conditions?